For step 2C, I'll start with the main function. I'll copy it from the HTDAP template and edit from there. For this program, our analysis task is to create a histogram that bins the natural increase of BC's population as a percentage. I'll rename the analysis function so that its name implies what it's doing. I'll call it plot histogram. In order to do our plotting, we need to import the PyPlot library from Matplotlib, so I'll add that to the top of our cell. All of our visualization functions will have a return type of none. They show the chart or graph, but do not return anything, so the return type for main will be none too. I'll update the purpose so that it describes what main does, and then write some examples and tests. Now on to the test for main. I'm going to copy these read tests because the input is the same. We know we expect none for main. And I need to change the name of the function that's being called. Since main returns none, our examples are not helpful for checking that the chart we've created is correct. But we still do want to write examples. They help us think through what input our function needs, and when we run them, they allow us to see that our function runs without errors, or maybe that errors are generated that we need to fix. It's very useful to refer to our example from step 1C, which shows us a visual example of what we expect our graph to look like. If I were to run these tests, I would get an error because I have not yet defined plot histogram. So let's write a stub for plot histogram and then run the main tests to see if there are any errors. So the function's name is plot histogram. Its input is a list of population change, because in main I can see I am passing the result of read to plot histogram, and read returns a list of population change. Its return type is none because it shows the graph or chart, in this case a histogram, and then returns none. Its purpose is to plot a histogram that bins BC's natural population increase as a percentage of total population and returns none. To complete our stub, we'll return none. I'm going to run the code before to make sure our new data definitions are defined, and then run this cell to check that our tests for main run without error. And they do. You may notice that all of our tests pass even though we have not yet finished designing plot histogram. That's because main expects a none output, and our stub is returning none. So of course we're not finished, but our tests are running without error, which is what we're hoping for at this point. Now let's complete the design of plot histogram. We've done our stub, so the next step is examples. And again, just like main, these examples will not help us check that our histogram is correct, but they will allow us to think about the input that plot histogram needs, and ensure that plot histogram runs without errors. I'm going to copy the test from main. They take different input, but produce the same output. so it's a decent start. I know that plot histogram takes in a list of population change, which happens to be the output from read. So I'm going to copy these and use these as the input for my plot histogram tests. Update the name of the function that we're calling. And now we have some examples for plot histogram. I'll run this cell again, and we had no errors generated. So now we can move on to the function design. Our next step is the template. For these visualization functions, we don't have a template in the same way that we do for our other functions. Instead, I find it useful to copy in the code from one of the worked examples and edit from there. So I'll comment out the body of the stub and paste in the code from a worked example. This particular worked example was plotting grades. So if we look at the first line of code, there's some comments describing it. And these are the bins. So for the grades, we wanted to bin the grades between 0 and 10, 10 and 20, 20 and 30, up to 100. For our problem, we want to bin the percentages from 0 to 0.1, 0.1 to 0.2, etc., all the way up to 1. So I will delete these comments because they're not relevant for what we're doing. They were about the grades. And change these bins so that they match the problem we're trying to solve. There's also a note about how you could design a function to create the bins. You can do that, but in this case we just wrote the bins out. I'll delete this comment so we can see more of our code, but if you did want to design a function to create these bins, you certainly have the tools to do that. So first let's update these labels, and then we'll come up to the call on line 25 that creates the histogram. As I type that string, I notice that I have a bit of a problem because I used single quotes to make the string, but I want to use an apostrophe in my string. An easy way to fix that is to use double quotes, because then it knows that that single quote is part of the string rather than trying to match the marker that shows the beginning of the string. There wasn't a title in the worked example, but I'm going to add one with pyplot.title. The next is the range for the axes. So it's xmin, xmax. So right now the minimum on the x-axis is 0 and the maximum is 100. The minimum on the y-axis is 0 and the maximum is 10. Because I've already looked at the data and I know that my percentages are going to range between 0 and 1, I'm going to change the maximum for the x-axis to be 1. If we left it to be 100, all of our bars would be very close to the left part of our grid, which is not what we want. And I'm going to increase this to 15. I'm not entirely sure whether that's an appropriate number, but once we see our graph for the first time, we'll be able to change it if we want to. Now let's go back to line 25, the call that actually creates the histogram. The first input is the grades. And remember, this is from our work example, so that was all of the grades that were going into the bins. So in this case, what we need is all of the percentages that we want to place into these bins. So I would like to have a variable called natural population increase percentages that stores all the percentages, so 1% for each year. Or another way of thinking about that is for our entire list of population change, creating a list of the same length that holds the corresponding increase in natural population as a percentage, 1 for each entry in the original list. In order to generate this, I'm going to need to call a helper function. So I'll say my natural population increase percentages equals get natural population increases, and I will pass LOPC. If I scroll up, was the input to this function. Now here I'm wishing that I had this helper function, and I'm going to need to design it. As this is a function that you can design based on everything you've already learned in this course, I'm not going to design it live in the video, but instead I will pause, copy and paste in the final design, and then continue. Okay, I have completed this function design. I'll quickly show it to you. So get natural population increases goes through the list and calls another helper, natural population increase, that takes a population change, calculates the percentage of total population, and rounds it to 3 decimal places. So now if I run my code, we can see that I have fully designed functions including tests for those 2 new helpers that I wrote. And we can see that our graph is roughly what we expect. These are just calls from tests, so they're not full data sets. And that all of our tests pass. Again, whether they pass at this point, if we're not sure that we're done, is not that important, but we are still hoping that we have no errors. Now, if we go back to plot, we can see that actually our function now is fully designed. We're calculating all of the data points. We're passing them into the histogram call. We're telling the histogram how to bin them, so between 0 and 0.1, 0.1 and 0.2, etc. So let's run all the cells, which will include running our call to main with our full data set at the bottom, so we can see if our graph produces what we expect. I'll scroll all the way down, and here we can see that we do have a histogram. We can see that the years between 1975 and 2012, the percentage of BC's natural population increase was always between 0.2 and 0.8. So what we've done is edited our HGDAP program so that now what it produces is a visualization. Let me go back to the plot histogram code. As we worked through the plot histogram code, we used a previous example and edited as necessary. We can see some changes we could easily make. So here we're saying face color is orange. Even without looking at all the options for the colors, I can guess that I could change that to blue or green or a different color. And imagine what that output would look like. But there may be other things that you want to change that you're less sure about. You can look at the Matplotlib documentation to try and make changes, or you can always ask us and we can try and help.